Hello and welcome to this screencast. Thank you for joining me. To begin with, I'd like you to just look at these pictures, look at these photographs of different species and have a think about what they might all have in common. There's a theme that joins all of them together, even though each of them is a very different species. So maybe write something down or just keep something in your head while you look at the different photographs. So we have in the top left-hand corner here a lionfish, which is native to the Indo-Pacific but has been introduced to the Atlantic and Caribbean. In the middle we have a water hyacinth, native to the Central America but now found throughout the world and very fast at reproducing. In the top corner here we have the European rabbit, famously introduced to Australia. Below that, the Nile perch is a giant specimen introduced into Lake Victoria in the 1980s. Below that is the cane toad, or the crapo as we call it here in Trinidad, which is native to Trinidad but has been introduced from Trinidad to other places such as Australia. And then finally in the bottom left-hand corner, the Trinidadian guppy, which is native to Trinidad and Tobago but has been introduced throughout the world for mosquito control and also as unwanted pets. So, if you haven't already guessed, all of these species are invasive species. Now, I imagine all of you have some idea of what you think invasive species means, but conservation biologists and ecologists have quite a specific definition, so we'll begin by dealing with that and talking about exactly what qualifies something to be called an invasive species. So today, we'll begin by doing that, defining an invasive species. We'll then talk about one particular example from the Caribbean, which will be the lionfish. We'll talk about how invasive species arrive, why they are bad and if they're bad, how we can stop them, and then we'll summarise what we've learnt at the end. So, beginning with what is an invasive species. So this is a hypothetical system here with a hypothetical ornamental fish. So you can imagine this pool in the top left-hand corner is its native habitat, and then it is transported to a new one here. And in fact, that's the first stage of becoming an invasive species. The species has to be introduced from its native range to somewhere outside of its native range, where it's not supposed to be. But that alone is not enough. It's not sufficient to be an invasive species. They have to survive, and that sounds simple, but in actual fact, about 90% of those species that get introduced fail to survive. They're not adapted to the habitat, it's too hot, it's too cold, something eats it, it doesn't have anything to eat. There are many different reasons which can cause the failure of survival in an introduced species. However, those 10% that do survive may then go on to establish a self-sustaining population. And this means a population that carries on reproducing without extra input from outside, no more introductions, and eventually that might grow or at least stay the same. And then the final stage, which is necessary before something is invasive, is that it has to spread from that initial area of introduction and have negative effects. And the spread and the negative effects are necessary before we can actually call it invasive. So there are different stages. At each one of these stages, some species will not make it down to the next one. So only very few are actually able to do these stages. But as we'll find out, those that do reach the spread phase and become invasives can be extremely damaging. And one of those very damaging species that is very successful when it's introduced is the lionfish. Now, this is a Caribbean example because it's actually native to the Indo-Pacific Ocean, but has been introduced to the Atlantic and the Caribbean over the last 20 to 30 years. Now you can see from this picture it's a very beautiful, spectacular species, and many people who are aquarium enthusiasts really want to have this in their aquarium. It's a real showpiece. However, it gets rather large, and it has venomous spines, and it eats everything else in your tank. So you can imagine many people end up deciding that they'd actually rather get rid of it, in which case many of them would rather irresponsibly or naively dump their unwanted lionfish into the ocean. And in Florida, the water is warm enough that they might survive. And actually, Hurricane Andrew is blamed for a lot of the introductions of lionfish because it breached a big aquarium in Florida allowing many at once to escape from that aquaria into the ocean back in 1992. So why is this a problem? Well, one of the reasons is that venomous lionfish actually corner their prey using these big pectoral fins, sort of trapping them so they can't escape. And then they strike. Now, the species that they have preyed upon for millennia over in the Indo-Pacific have strategies to avoid being eaten all of the time. Sometimes they get eaten, but sometimes they manage to escape. However, the equivalent fish in the Atlantic, have never had to deal with a predator like this before, so they don't have a method of avoiding it. They're naive to the strategy, and so the lionfish is much more damaging on those populations than it is on the populations in its native habitat. And for this reason, because coral reef fish are very important to the health of coral reef ecosystems, the lionfish may have a severe negative impact on coral reef ecosystems as a whole, not just on the fish that they actually eat. And this has actually been demonstrated in the Bahamas, but most likely this is the case throughout the Caribbean. So, how fast do they spread? This is a really interesting study where they mapped the spread of lionfish over time. So from 1999, you can see it's a localized distribution around the coast of Florida. And then it sort of spreads up over the first few years. And then it spreads down as well. And we end up finding it coming down through the Caribbean until it reached Trinidad in around 2011, 2012. And in fact, an update on this is it's now reached right around the coast of Brazil as well. So that's just one way in which they arrive, aquarium, release and then spread. But there are several different routes at which invasive species can take. One of the most unusual is ballast water, and we don't really think about this because it's just water, but of course seawater contains many different larvae and plankton that are the juvenile stages of other organisms. One of those is mussels. Mussels have planktonic larvae that are almost microscopic, but when they grow up they can actually become large organisms that can be problematic, and we'll look into that just now. And the way ballast water works is that a ship that is crossing the world will fill up its ballast space with water from that place, and then it will go to where it's picking up its cargo, and it will replace the water with cargo, and so that water will be dumped in the new place. And that's just to keep its buoyancy, so they have to have a certain weight to sit in the water correctly. But what that means is water from one place gets dumped in a whole new place, and any of the organisms that are in that water also get translocated. Another method is discarded pets, as we saw with the lionfish, and that's also what happens with the guppy. Then biological control, which is also the case with the guppy for mosquito larvae. This is the case where the cane toad was introduced to Australia to control this beetle. So why are invasive species bad? We've looked a little bit at how the lionfish is bad for coral reef ecosystems, but actually that's not an isolated case at all. In fact, after habitat destruction, invasive species are thought to be the greatest threat to biodiversity worldwide. And even though only a very small proportion of those that get introduced actually become invasive, those that do have a devastating economic and ecological impact. So we've talked about the ecological impact for lionfish, but a very nice example of the economic damage is these mussels that get spread through ballast water. And even back in 1997, the invasive zebra mussel was causing between 3,000 and 5,000 million US dollars in damage to factories and in industrial plants by blocking the pipes. So the little larvae come up the pipes in the water, but then they settle on the side of the pipes and they grow into these structures that actually block the pipe, causing real problems for the companies that have to maintain them. Another example is from Lake Victoria. This is a very famous example of an invasive species. The Nile perch was introduced for protein. It was a very big fish that could really feed lots of people. However, Lake Victoria was full of these beautiful native cichlid fish. But as soon as the Nile perch was introduced, they began to decline because they were being predated upon by the Nile perch, but also competing with other species that were introduced to feed the perch. These are just some of the beautiful different colours and patterns of the Lake Victoria cichlids. And about 110 different species of cichlid were counted back in the 70s, But 10 years later, only 10 of these were still present in the lake. And the status today is that at least half of these are completely extinct, and a few others are in captive breeding programs. All because of this Nile perch decimating the ecosystem. So, can we stop them? Surely there must be a way in which we can. Well, yes, there are different stages at which we can intervene to minimise the damage of invasive species, but there are problems associated with each one, and you also have to think about them on this scale of less costly to more costly. So beginning with prevention, one way to prevent invasive species in the first place, which is obviously the most effective thing to do, is border control. Australia and New Zealand do a very good job of this. They screen everybody's luggage for plant matter and animal matter, and anything that might have a tiny risk is not allowed into the country. Early detection is the next best thing. If you can catch something before it's spread too far, then that can really minimise the amount of resources needed. However, with many species there's a time lag, so it may take several months or years after an introduction before the invasion takes place. So early detection is sometimes not possible, but because by the time you've detected it, it may be too late. Eradication, it sounds great, but it's very difficult and very expensive, particularly in aquatic habitats like rivers and the sea, where it's very difficult to completely eradicate every single one. If you even leave one or two individuals, then that can they might re-establish, and then you're back to square one, and the money is wasted. Control is another method, but that brings with it its own problems. So control is admitting that you're never going to eradicate, but having a program where you just say indefinitely we're going to do something to manage this by, say, culling or controlling in some way by chemicals, by physical control methods or biological control methods, like with the cane toads eating the beetles. But biological control can make things worse. So the cane toad was introduced to eat the beetle, but now the cane toad is a problem in itself. And in fact, it's only about 10% of cases that biological control is successful. The other 90, many of those sort of flip over and become more problematic. So let's just summarise what we've learnt today. The first thing is to remind ourselves of that definition. Invasive species are species introduced outside of their native range, which then spread outside of that initial area of introduction and cause negative effects. They can arrive by various routes, including ballast water, including aquarium pets that are discarded, and biological control. They can cause significant economic damage, as is the case with the zebra mussels, and ecological damage, like the lionfish on coral reefs. And finally, it's always more cost efficient and effective to prevent the species from being introduced in the first place than trying to eradicate them afterwards. And one of the things that invasion biologists are very keen to do is to try and identify which species have the predisposition to be invasives, so that we can, rather than stop moving all of them, we can concentrate on those that are high risk and prevent those from being introduced. Thank you very much for listening. I encourage all of you to, having watched this, go and research one example of an invasive species, maybe one that's in your country, and find out more about it in relation to the things we've talked about today.